Hey, so let's conclude this little trip to the glaciers with this piece on what evidence is generated that stays behind even if the glaciers disappear. Why is that important? Because we said because of the changes in the sun's energy coming to earth, because of the change in the ellipticity of the orbit around the sun of the earth, orbit of the earth around the sun, because of the change in the tilt and because of the change in the precession. If you don't know what these mean, I have podcasts before in this course, so you can look up. Energy distribution and amount of energy received can change, and then a lot of internal feedbacks happen to amplify the signal or create a vicious circle. What is one of those amplifiers? It is, of course, what you just learned. It's the ice albedo feedback. If the energy reduces a little bit and you begin to build glaciers, then albedo keeps going up, which means more and more energy is reflected, less and less energy stays in the system. It gets colder and colder, and the glacier begins to grow more and more, and vice versa, where if the energy increases a little bit and the glacier begins to melt, the albedo decreases. More energy is kept in the system because less is reflected. It gets warmer, it melts more glaciers, albedo becomes even lower, and before you know it, you have melted away the glaciers, which is what we are doing now, except we are not changing the albedo by melting glaciers through changes in the orbit. We're doing it by increasing the greenhouse gases and trapping more of the energy in the system and melting glaciers, reducing albedo, increasing temperatures more and reducing albedo more, and we are in a vicious circle that we have to worry about. So, the evidence that is left behind to go back in time to figure out when there were ice ages and so on, you need to figure out how old that evidence is, which you can do using something called carbon isotope, carbon dating, or some older isotopes, uranium, lead, and there are many isotopes which allow you to go back to a billion years or millions of years and so on and so forth, that we will not talk in this details here. But if you are old enough, then you can go to a course on my YouTube channel, which has a full course on past climate of the earth and future climate of the earth as well. So let's come back to the evidences. So as the glacier forms, it can creep into the rocks and break it into pieces. If you live in cold places like Minnesota or Alaska, you've probably seen when winter comes, the water seeps, snow falls, and it melts and seeps into the cracks in the streets and so on, and then it keeps freezing more and more, and it can, it's strong enough that it can begin to break the road apart. You will end up with a lot of potholes and so on. So if you're old enough, you probably heard the joke that in Minnesota they have two seasons, winter and construction, which means after the winter they have to start to fill all the potholes and so on and so forth. So glaciers also scratch the rock surface when they grow and flow, and they move these pieces of rock that they create in different directions. So on the side it will create something called a lateral moraine. As it grows and stops somewhere, it leaves a pile of debris that it pushed ahead of it, and it's called a terminal moraine. So moraine is the key word, which is the debris of various sizes that is created by glacier growing and breaking things into pieces and sweeping them in. So if you go somewhere in the middle of Nebraska and see you evidence of rock pieces that don't belong there, then you think, wow, that looks odd. It's a nice rolling hills, and suddenly you have a pile of rock that's come from somewhere. Could be that in the past glacier came down there and put up some terminal moraine, or you have lateral moraine as before, and the glacial flow is in this direction, and you have superglacial moraine, which is basically the rock and the dust and the soil collected by the glacier as it keeps flowing and keeps carving out material. And there is a moraine in transit, it's still moving, and there is a medial moraine which is in the middle of two glaciers coming from both sides, and there is a bed load. So this is the bedrock which is below the glacier, which is supporting the glacier. In fact, the glacier can get so heavy that it pushes the crust bedrock down, because the deeper layer of the Earth's crust is Earth's lithosphere is somewhat squishy. So if you put a lot of weight on it, it can give way and the plate can sink, and when the glacier melts, it can come back up just like that. Okay, so these changes do happen. There are parts of geology and paleoclimate, past climates, and so on. So here is a nice moraine, and you can see various kinds of material, big rocks, small rocks, almost pebbles, and some soil created as well, and you can see the rock being carved out and so on. And this was a glacier at some point that has flown in, and maybe it was this deep and then it is dried away. Okay, so this is how you go there and do some detective work. So next you're out there and hiking somewhere, it may not be as cold as holding a glacier right now, but it may have evidence of glaciers from the past, because maybe the last ice age reached the place you are visiting somewhere. Okay, so these are another kinds of evidence. These scratches on the rocks, they are not happening by any other process from what we know from science and geology. They are basically happening because glaciers grew and they made these scratches as they froze and they grew, and as glacier flows on the rock, it is jagged at the bottom and it keeps scratching the surface. These are called glacial striations, S-T-R-A-T-I-O-N, striations. Okay, so you can see some glacier material over there as well, and the rocks carved into various shapes, and the rocks, they are debris is carried by the glacier as it flows, and it leaves it where it reached and goes back. So you can always find rocks that don't seem to belong there, and then you know that maybe the glacier brought it along and dropped it there and went away, and so on. Okay, this is some data from the Himalayan mountains. It's called the Shorabari Glacier in the region of Mandakini Valley. So this is photograph showing different stages of a glacier moraine that I'm not going to go into, but you can see some glacial melt. River is still flowing there with very little water, and this is the Kedarnath temple, which is the famous temple that got massively flooded a few years ago, and then it was considered a miracle that despite all that massive amount of water that wiped away houses and the truck going by and killed a lot of people, the temple remained intact. So maybe people have built it from past experiences to stay above the flash floods that get created by glacial melt and so on. And you can see pieces of rocks of all shapes and soil being formed. Okay, so this is different stages of a glacial moraine evidence. So this is how you would go back in time, not only through the glacial core and look at past CO2 levels, greenhouse gases levels of methane and N2O. You would look at dust and pollen and figure out whether the rainfall was reduced, what kind of vegetation may have been there, and so on and so forth. But you would also look at these evidences in moraines to figure out what happened in the past. Amazing detective work, really fun work. You get to do amazing field trips to nice places and sometimes dangerous places, so you have to be careful. But when you grow up and you do research in these areas, or you do an internship where you go and work with a scientist who's doing this kind of work, and you get to go and learn these things and help the scientists with their research by collecting samples, doing some lab work, and so on and so forth. Okay, so go and read more, look at YouTube channels, and see if you can go have fun if you're old enough, or dream of becoming a glaciologist as you grow up. Okay, see you in the next chapter, which is going to be about what? Let me find out. That is going to be about something in the air. So we are increasing pollution as well. So we'll talk about that when we come back and continue. Okay, see you.